Hi, this is Mr. Russo, and this is a lesson on solving one-step equations. This packet I gave to my students in class, and there are certain problems that I used right from the packet where we just solved them in class, and we did it step by step, and when they do their homework assignment, they're to do it the exact same way. Okay, so we did this one in class, we started off with, and even though it's an intro to algebra class, we're going to still do it the same way that they learned it probably in pre-algebra. So if we have this first equation, and I want to try to solve for v, I'm just going to look at the 8, I look to the left, I know it's positive, and we do the opposite of positive, which is negative, so I'm going to subtract 8 from both sides. When I do that, 26 minus 8, I'm going to get 18, and I know if I were to use my integer rules, when adding and subtracting and the signs are different, I subtract and take the sign of the larger, which is positive, and I get a positive 1v, or just v, and as long as I get a positive 1v, I'm done, and I solved the equation. Okay, I'm going to jump to number 5. Number 5 was the next one that we did in class. And if I take a look at this problem, as long as there's a plus or a minus sign in between the number and the variable, then I know I'm adding and subtracting. So I always do the opposite. I would always do the inverse operation. So if it's a positive 4, I'm going to subtract. So subtract 4, put my line across, my 4's cancel, and I get m equals, and then if the signs are the same, I add and keep the sign, so I get negative 16. That's it. Okay, the next one was number 7. And if I look at this one, it's set up the same where there's a plus or a minus in between. So I'm going to add 9 to both sides. I'm doing the inverse operation. My 9's cancel, and I get m equals, when the signs are different, I subtract and take the sign larger, so it's going to be negative 4. Then from here we did the last 2 odd problems, and number 11 was the first one that we did in class for notes, where if there's no plus or minus in between the number and the variable, then that indicates multiplication. And again, the inverse operation is to opposite of multiplication is division, so I'm going to divide both sides by 8. And then if I can't do the division in my head, I'm going to show the long division on the side. So 104 divided by 8, and then 8 goes into 10 one time, 8, subtract, I get 2, bring down to 4, 3 times, and it goes in perfectly 13 times. So a negative divided by a positive is a negative, and comes out to be negative 13. The 8's get crossed out, and I get x equals negative 13. Okay, number 13. Here I like to rewrite this equation. If it's set up where it's an integer equals a fraction, I like to set it up as a proportion. A proportion is a fraction equal to a fraction. So I'm going to rewrite this as negative 6 over 1 equals b over 18. And then a very common way to solve a proportion is to cross multiply. Cross multiply, we're going to do 6 times 18, or negative 6 times 18. So 18 times 6, 48, 4, 104, and then negative times a positive is a negative, so it's going to be negative 108 equals 1 times b is just b, And since we got b alone, the answer is negative 108. Okay, there were a few more that we did in class. On the next page, we did numbers 17, 19, and 25. So let's do 17. So over here, I look in between the number and the variable. If there's no plus or minus sign, that means multiplication. So I'm definitely multiplying. The opposite is to divide. And it was divide by whatever I do not want. I want the x alone. So I divide by negative 15. Divide by negative 15. That cancels. And I get x equals, and then 0 divided by any number other than 0 is 0. So x equals 0. Alright, we got two more to do. Number 19. If I have 21 equals negative 7n, I have negative 7 times n. So in between here, there's no plus or minus. That means multiplication. Just going to try and make this a little bit clearer. So we know that we're going to be dividing by negative 7. And then from there, the 7s are going to cross out. And then 21 divided by 7 is 3. Positive divided by negative is a negative. So n equals negative 3. Alright, last one, number 25. Here I look in between. There is a plus or minus in between the variable and the number. So now I know I'm adding and subtracting. So now I have to use my inverse adding and subtracting rules. So if it's a negative, I add 15 to both sides, cross off my 15s, and then I have x equals, and then negative 17 plus 15. When adding and subtracting, the signs are different. I subtract, take the sign larger, get negative 2. Okay, that was basically it. There's only one additional rule, an additional example I wish to show. If I had an example like this one, if I had negative 17 equals negative x minus 15, I would do all of the exact same things. I would add 15 to both sides. I would still get rid of the 15s. I would still get negative 2 here. It would equal negative x. I always look to the left and include the sign. And at this point, if I ever have a negative x or a negative variable, you divide both sides by negative 1, and then you'll be left with just x. So if I divide by negative 1, divide by negative 1, a negative divided by a negative is a positive, 2 divided by 1 is 2, so the answer is x equals 2. Alright, thanks for watching.